All right, welcome to The Explainer. Today, we are really unpacking a big one, climate change. We're going to look at everything from the huge global agreements all the way down to the nitty-gritty science that you hear in the headlines.
So let's just jump right in with a pretty shocking number, 50%. We're talking about nearly half of the entire population of South Asia. And a huge chunk of those folks are now living in what experts are calling climate hotspots.
So you're probably asking, what exactly is a climate hotspot? Well, think of it as a place where life is just getting harder and harder because of the climate. We're talking about a combination of things, like crops failing because the weather is all over the place, or heat so intense it's not just a health risk, it actually stops people from being able to work. And the hit to the economy? It's just staggering. And listen, this isn't some forecast for the distant future. This is happening right now. For a country like India, for example, the loss is already estimated at a whopping $206 billion.
Now, to wrap your head around that number, that's almost a tenth of its entire GDP. It just goes to show you the massive financial price of doing nothing. And it's not just about one country, right? It's about the whole interconnected global economy.
But, these numbers, they're really just the tip of the iceberg. They're all part of a bigger picture, kind of like the vital signs of a planet that's really feeling the pressure.
Yeah, the data really tells a story here, and it's a pretty clear one. You look at the top of the world, and the Arctic sea ice is just vanishing at a scary rate. Then you look at our oceans, and their actual chemistry is changing. They're getting more acidic year after year. We've lived through the warmest decades ever recorded, and now huge cities, they're facing these incredible, life-threatening heat waves.
Okay, so with all of these warning signs flashing red, the big question is, what has the world actually done about it? Let's take a look at the major global pacts that were created to try and tackle this whole thing head-on.
You can actually see this strategy change over time. It all started back in '92 with just a basic framework. Then came the Kyoto Protocol, which is a big deal because it set the first ever binding targets. But that was only for developed countries. The real game changer was the Paris Agreement in 2015. That's when everybody came to the table. And since then, we've even gotten more specific deals, like the Kigali Agreement, which goes after those really potent super-polluting gases.
And if you boil the Paris Agreement down to its core, it's really all about this one single supercritical goal. This is the target, the guiding light for pretty much all climate action now. Keep the warming well below 2 degrees Celsius, but really try to hit that safer target of 1.5 degrees.
So how does it actually work in practice? Well, instead of some global body telling every country what to do, the Paris Agreement is built on this idea of nationally determined contributions, or NDCs. Basically, it asks each country, hey, what are you going to do? What's your plan? And, this is the really clever part, it makes them come back every 5 years and make that plan even stronger.
So, that's the global goal. But how does that actually turn into a real plan on the ground? To see that in action, let's zoom in on India. I mean, they're one of the most important players in this whole equation, so they make a perfect case study.
All right, so as it's part of the Paris deal, India laid out 3 main promises. First up, get more efficient. Basically, reduce the amount of emissions it takes to grow its economy. Second, make a huge switch over to clean energy. And third, help nature do its thing by creating what's called a carbon sink, by planting a ton of trees and restoring forests.
And that second promise, wow. Just look at the scale of it. They're committing to get a full 40% of their power capacity from clean sources by 2030. That's not a small tweak. That is a massive, fundamental shift in their entire energy system.
Okay, but here's where the story gets a little weird, a little counterintuitive. It turns out it's not just about the gases that are warming everything up. There are other pollutants that have been doing the exact opposite. They've actually been cooling the planet down.
Yeah, it's a real thing, and it's called global dimming. It's mostly caused by all these tiny particles we shoot into the air when we burn fossil fuels, stuff like soot and dust. And what these little particles do is act like a giant planetary mirror, bouncing sunlight back into space before it even has a chance to heat us up.
So you've got these two forces basically fighting each other. On one hand, greenhouse gases trapping heat and warming us up. On the other, these aerosol particles reflecting light and cooling us down. For decades, this dimming effect has actually been hiding some of the warming. So here's the crazy part. As we clean up our air, which is obviously great for our health, we might actually see the warming speed up because we're removing that cooling mask.
And that brings us to the final piece of this puzzle, which is really getting to know the enemy, so to speak. We need to understand that when it comes to greenhouse gases, they are definitely not all created equal. Some of them pack a way bigger punch than others.
So how do we measure that punch? We use a scale called the Global Warming Potential, or GWP for short. It's basically a power ranking. We take the most famous greenhouse gas, carbon dioxide, and we set its power level to 1. Everything else gets measured against that. And this right here shows you just how massive the differences are. Let's stick with that blanket analogy. If CO2 is one standard blanket, then methane is like piling on more than 20 of those blankets. It's like a super thick quilt. But then you get to nitrous oxide, and oh my gosh! That's like wrapping the planet in a blanket made for an industrial furnace. It's 310 times more powerful. You can see right away why we have to focus on these other gases too.
So, where does that leave us? Well, we've got the global agreements, we've got the national plans, we've got a much deeper and, yeah, sometimes surprising grasp of the science. The blueprints are there. So the question really isn't what we need to do anymore, it's how we do it. And maybe the most important question of all, are we going to do it fast enough